Hello students, today we will discuss the most important topic, that is errors in measurement. What is an error? Before before the discussion of error, let us know about the measurement. Measurement is the base of science. That is base of science, right? Everything is based on measurement and the observations. Okay, so in measurement we have two things. One is our true value or the actual value, and second is your observed or calculated value, right? If there are some differences, or there is some difference between these two values, then that difference is known as the error. So what is error? Error is true value minus observed value. Okay, for example, if true value is 6.7 centimeter and observed value is 6.6 centimeter, then error will be 6.7 minus 6.6, 0.1 centimeter. That is positive error. In another example, if true value is 6.7 centimeter and observed value is found to be 6.73 centimeter, now error will be 6.7 minus 6.73, so it gives us 0.03 of negative. So this is our negative error. So we have two types of errors mathematically. One is positive error and second is negative error. But we can minimize the errors. There is one term, that is error can never be subtracted. Error can never be subtracted. See, if we have committed any mistake in our life, then we cannot eliminate that mistake at all. But we can do one thing: we will not repeat that mistake in our future. This is the difference between the elimination and the reduction. So we can't eliminate the errors, but we can reduce the errors, or we can minimize the errors. Now we will discuss about the types of errors in measurement. So students, these are some types of errors. We will explain these one by one: systematic error, random errors, gross errors, least count errors, and constant errors. And for error, there is one term, that is ECNBS. Error can never be subtracted. This is the principle of error. Error can never be subtracted. But can be minimized. But can be minimized. Right? Okay. One is systematic error. What is a systematic error? Systematic error basically comes into existence due to some technical problems or some personal mistakes. Okay, and these are of either positive or negative. It may be positive error or it may be negative error, but we can minimize these types of error. So there are some types of systematic errors. One is your instrumental errors, second is personal error, third is errors due to external causes, and last is your imperfection in procedure or the technical procedure. So first I am taking instrumental error. Suppose I have any instrument, say scale, simple scale, and this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, like so on. Okay, this is our actual scale, but somehow by mistake it breaks. Now my 0 is not here. So earlier 10 divisions was there, which is equals to 1 centimeter. So 1 division is equals to 1 by 10 centimeter, means 0.1 centimeter. This is the least count. This is the least count of this scale. But now here my 0 is not there. If I measure this length AB with the help of this broken scale, and the actual length, suppose actual length is our 17.8 centimeter, right? But with help of this scale we are not able to measure it accurately, and we found it like 17.6 centimeter, right? So this is the first type, the instrumental error. If there are some defects in the instrument, then that instrument will give us the measured values with the errors, right? So this was the first type. So we can eliminate this type by taking the good instrument, the good working instrument. Second is personal errors. Personal errors maybe depends on our mood, so that we are not in mood to do some work, or while measuring some measurements, while taking some measurements, we are not taking proper precautions, and due to our carelessness, these are some factors which are including in this type, personal errors. Next is errors due to external causes. Say I have good instrument and I have proper knowledge of handling the instrument, and I am ready to take the measurement. But instead of having these things accurately, temperature is not favorable for my body. Temperature is either very high or very low, right? Or velocity of wind, or you can take humidity. So these are some natural factors, climatic factors. If these climatic factors are not favorable, then there are some chances of having some errors in our measuring process, right? Next is imperfection in procedure. Imperfection in procedure, or the lack of knowledge while handling the instrument. If we are not able to handle the given instrument for the measurement, then we are not sure that we will give the 100% accuracy in our measurement. So these were the parts of systematic errors, and we can minimize these types of errors by eliminating these things, by taking good instrument with proper knowledge, with proper handling, and with favorable conditions, right? Next is random error. Random error means, because systematic errors are the continuous errors. If I have a broken piece of scale, then errors during the measurement will remains continue, right? But random errors, these types of errors are exist irregularly. It may be positive error or negative error. It may be small or it may be large. Or maybe large, right? So these are the random errors. We cannot eliminate these type of errors. We cannot eliminate this type of error, but we can minimize. We can minimize random errors by taking average value or mean value. Fine. So this was about the random error. Next is gross error. Next type is gross errors. Gross errors are due to the following reasons, maybe one or maybe more than one reasons. First reason is improper adjustment of the operators. Second is recording observations wrongly. Third is not considering the precautions and the sources of errors, because for every kind of observations we must follow some precautions and sources of errors are there. So if we will not consider those precautions or we will not take the precautions, then might be some errors are there in our observations. And last is using wrong values in calculations while calculating the recordings or while the calculations is being going on. Then if we take the some different values during the calculation, then our answer will be different from the actual answer. There is one method for this type of error, how to take the readings. Suppose this is a length AB and I want the measurement of AP. Out of AB I want a measurement of AP. So I am using a scale and suppose this value, let it be 10.7. 10.7 coincide with this one, that is the true value, and this is 10.6, this is 10.5, this is 10.8. okay, if I observe the reading in this way, my contact must be, this is the actual point of contact, so my eyes should be at this angle. Okay, but if I take the observation like this, then that line must coincide before the exact value, and if I observe like this, then that point will coincide with the further values. So this method we have to adopt during the observations. So angle of vision should be straight, right? Next is least count errors. What are least count errors? I told you earlier what is a least count. Least count means the minimum value that can be measured by any instrument is called its least count. For example, a normal scale is having least count as 1 by 10, that is 0.1 centimeter. For vernier caliper, okay, that is 1 by 100 because 100 divisions are there, that is 0.01 centimeter. Okay, and for spherometer and screw gauge, least count is 0.001 centimeter. Okay, so liability for the measurement for scale is 1 by 10 part. For vernier caliper, that is 1 by 100, and for spherometer or screw gauge, that is 0.01 centimeter. And you can understand this thing with the help of one example. Say I am measuring a diameter of any ring. With the help of scale, I found the diameter is 3.4 centimeter. With the help of vernier caliper, I found it 3.43 centimeter. And with the help of screw gauge, I found it 3.432 centimeter. So this is having larger number of significant digits. So this value, this measurement will be more precise as compared to these two. So these are the some least count errors. It depends on the instrument and its least count. Last is constant errors. Constant errors are those errors which repeat itself after every measurement and with the same values. So these are your constant errors which repeat itself with every measurement. Okay, so these are the some types of errors. Now we will discuss how to minimize or how to reduce the errors. We have some methods to reduce the errors.